Hello everyone, and welcome to the Pandas built-in data visualization lecture. In this lecture, we're going to go over Pandas' own built-in capabilities that are actually built off of Matplotlib, but they allow you to call data visualizations directly off a data frame. Let's go ahead and jump to the Jupyter Notebook. Alright, here I am at the Jupyter Notebook server. Quick note, you should be opening this Jupyter Notebook under Python for Data Visualization, the Pandas built-in data viz folder. And the reason for that is there's a couple of CSV files here called df1, 2, and 3. And these are CSV files that we're going to be working with to actually show the capabilities of Pandas built-in data visualization. The lecture notebook is right here. It says Pandas built-in data visualization, and then you also have an exercise which we'll go over later. I'm going to go ahead and open a new notebook here and go ahead and get started. Alright, here I am at this notebook, and I'm going to go ahead and say import numpy as np. I'm going to import pandas as pd, and then I'm also going to specify matplotlib inline so I can see the data visualizations inside of this actual notebook. And then the CSV files that we're going to upload are df1, so I'm going to say pd read CSV, pass in df1, and for df1 I'm also going to specify that the index be the first column at index 0. So now if I look at df1, I can see that the index is actually a time series. And that's going to be important when we actually visualize that out. And then for a non-time series index, I'm going to go ahead and say pd read CSV, and then pass in just df2. And then if I take a look at df2's head, it's very similar, except this is just random data, and it has a sequential index. Alright, let me go ahead and just show you a quick example of what you can do with these sort of data frames and these columns. Imagine we wanted to get a histogram of all the values in the A column for df1. Well, pandas can actually do that directly. We can just call df1 and then call hist off of this, and it will actually automatically start creating a histogram. And note that it's actually calling matplotlib under the hood. And then you can begin to add in matplotlib arguments or even Seaborn style arguments like the number of bins you want in this histogram. Okay, now something to note is this style actually isn't very good looking in my opinion. So what you can do in order to fix that is if you come up to the top or really anywhere in the notebook, go ahead and say import Seaborn as SNS. And once that's imported, if you start running these cells again, it will look like a Seaborn plot. It'll look a little nicer. So that's something I like to do. You can actually set Seaborn styles, and the pandas calls will look like them. Pandas has several plot types built into it, and what we're going to do is just briefly go and show examples of how to create these plots. Pretty much all the plots can be done through a command off of the data frame. And you can basically do this with two methods. You can call the data frame itself or call a column off the data frame. Let's go ahead and just do a column now. And you can call plot, and then under the argument of plot, specify kind. And there's a list in your notebook, and we're going to go throughout this list. And then you specify the keyword of the kind. So if I wanted a histogram, I could also create it this way. And then here you can add in histogram arguments, such as the number of bins you want. So that's one method of creating, for example, a histogram off of a data frame column. You call .plot and then call kind. Alright, the other way you can call a plot using pandas is instead of specifying kind equals hist, you can actually call hist directly off of plot. So you can say .plot and then .hist, and this will also create the plot. This is the method we're going to be using throughout the rest of this lecture. So we're going to either grab the entire data frame or the column, call .plot, and then call whatever the plot type we want. Let's go ahead and just go through all the plot types and check them out. So let's go ahead and work with df2, which is the non-time series. So as an example, it just has a normal index. And one plot you can do is an area plot. So you can go ahead and specify plot.area, and this is essentially just going to show an area plot. And what you can also do is specify alpha as an argument here if you want some more transparency. So you can say alpha is equal to 0.4, and this shows some transparency here. And this is just showing the area of the values. You can essentially just think of this as a normal line plot, except the area underneath it has been filled in with some sort of color. Alright, that's an area plot, and again, just very easy to call off the data frame. Let's go ahead and take a look at bar plots. So you can say, pass in your data frame, df2, plot, and then bar, and this will automatically create a bar plot. And what this does is it just takes the index value basically as a category. So in this case, your index should be categorical. Our data frame is actually small enough so this makes sense. So if we take a look at the data frame, it only has 0 through 9, so this works. A typical data frame with a sequential index, you probably wouldn't want to do this. But if it's a categorical index, then as a category, it'll just list the values per each column. And you can actually also create this to be stacked by passing in stacked equals true. And you'll get a plot that looks like this. Basically the exact same thing, except it's stacking the values. Now personally, I would actually recommend that you use Seaborn for these types of plots, but if you're just doing some very quick analysis, this sort of thing is going to work for you, just calling it off of pandas. Now let's call histogram, just to clarify what it looks like again. So I'm going to call, let's say df1 a.plot.hist. We've seen this before. And here's our histogram, and you can specify the number of bins you want. So if we want a larger number of bins, in order to get a little more clarity. As far as pandas plots go, and doing stuff that's built into pandas, histograms are probably the one I use the most. You can also do line plots, which is another common one that I like to use for pandas. For example, if we check out df1, remember that's our time series index. Let's imagine that we wanted to plot the data of one of these time series. We can go ahead and just say df1 plot, and you can call line. This is just going to create a line plot. And for the line plot, you have to specify the x and the y. So in this case, I want the x to be my actual index. So I can say df1.index, and I want my y to be one of these columns. And you pass in the column as a string. So I'm going to go ahead and just pass in, let's say, b. And if I just run this, I get a plot that looks something like this, essentially just a line plot. So you can imagine if this was stock information and you wanted to plot it out versus time, you can get something that looks like this. And since this is all built off of matplotlib, you can begin adding matplotlib arguments, such as the fig size you want. So let's say we want something much wider. You can do something like this. Or let's say we wanted to adjust the line width. Well, you can just do LW, just like we saw for matplotlib, and set the line width to something a little skinnier. You can add in markers, all these other matplotlib commands. So everything you've learned about matplotlib can be applicable to these data frame plots. Now let's go ahead and check out scatter plots. So let's say I have df1, I can say plot.scatter, and you're going to have to specify an x and a y. So for this, let's just go ahead and pass in strings of column names. So A and B. And this will create a nice looking scatter plot for us. Something else you can do is actually set the color based off another column. So for instance, you can say C, the color is going to be equal off column C. So if I just run that, it gets me a black and white. So if I take a look at df1, just to clarify what we're doing here, data frame 1, we have a value for A and B, and we have a value for C. So essentially we're showing now 3 levels of information, a 3-dimensional plot, if you will, since we have A versus B, and then a third argument, C, displayed by color. And you can actually pass in CMap as an argument and pass in your own color map. So for instance, cool, warm, which you've seen before, and now you're showing 3 levels of information, A versus B, where they stand, and then the color value for C. Sometimes people don't like to show things by color, but prefer to show them by size. You can actually do that as well. Instead of passing C as an argument here, you'll just go ahead and pass in S. And for S, you'll go ahead and pass in a data frame column. So for this, you have to actually pass in the data frame column itself. And you probably, if you just do this, the points will be too small. And what you can do is multiply this by some sort of factor. So now you can see the points are A versus B, and the size indicates how large their C value was relative to each other. All right, and this is the kind of thing where you probably wouldn't remember this all off the top of your head. You would go back to the Jupyter Notebook that I've assembled for you and use that as a reference, or check out the documentation. Let's go ahead and move on to box plots. Again, I really like Seaborn for box plots, but if you just want a quick analysis of a box plot, pandas can do that for you as well. So you just pass in your whole data frame, call plot, call box, And here you can see a box plot that's basically automatically done for you per column. So it just takes every column as a category and then plots the distributions for you as a box plot. All right, for bivariate data, you can do a hexagonal bin plot, which you've actually seen before with pandas, or excuse me, with Seaborn. But let me go ahead and make a new data frame for this to actually show up correctly. So I'm going to say PD data frame. I'm going to pass in some random data, rand_n, and I'm going to have this be 1000 by, let's say, 2. And then I'm going to pass in the columns to be just A and B. And if we take a look at our data frame, it looks something like this. Just some random data, A for B. I just wanted some more random points here. And what I can do, since this is bivariate, or two variables here, A and B, I can say plot.hexbin, pass in x is equal to A, pass in y is equal to B. And if you just do this, you will get a hex plot. Now this is essentially like a scatter plot, except it's the hexagonal bins. Right now the bin size is really quite small. So to change that, we can say grid size is equal to 25. And this will enlarge the size of the hexagons. And essentially the hexagons get darker as there's more points inside of them. And you can also change the color mapping here. You can say CMap is equal to something else. So for instance, if we wanted cool warm to be our color mapping, you could do that as well. And then finally, we can do kernel density estimation plots. So if for some reason you don't just want a histogram, but you want a kernel density estimation, you can call your data frame or a column off your data frame and then just say plot KDE, and it will create this kernel density estimation plot for you. And you can do the same thing with density, which is another call you can make. So you can say density, and that will be the same thing. So if you want a density or kernel density estimation plot, those will be the same thing. And you can actually do this off the entire data frame as well. You don't have to do it just off of one column. If you wanted to compare the density, kernel density estimation plot of all the columns in your data frame. All right, that's it. Hopefully you can see why this method of plotting directly off of pandas is a lot easier than calling full matplotlib, and it balances ease of use with control over the figure. You should note though, if you really want to start customizing your figure, you should be falling back to Seaborn or matplotlib. These sort of commands are really just for a quick analysis of your data, and you'll probably just go to the notebook, quickly reference the kind of plot you want to create, and then call it off the data frame or call it off the column of the data frame. As far as how we're going to use this throughout the course, really the only times we're probably going to use this is just with a line plot or a histogram to call it very quickly. For more advanced statistical plots such as box plots or bar plots, I would really recommend going with Seaborn. Okay, I hope you found this useful, and I will see you at the next lecture where we're going to describe the quick exercise for you to practice what we just learned here. Thanks everyone, and I'll see you at the next lecture.